So this lecture is going to cover the basics of the periodic table, an introduction to its structure, and some details about it. Here are some key concepts that we'll be addressing. I'm going to ask you to know the basic organization of the periodic table and some of the labels for how it's how we distinguish certain groups or periods. Also, I'd like you to locate metals, nonmetals, metalloids on the periodic table, and knowing some basic properties of each type of element. So what makes a metal, what makes a nonmetal, what makes a metalloid from a properties standpoint, as well as where they are. And finally, a pretty simple task is there's family names for the different columns or groups, and you're going to need to know those as we move forward because we're going to refer to them a lot, and you also want to know why they're called families. So here it is, our beautiful periodic table. Like I've said, it's often seen as a bit of an instrument of torture, but really it's a very concise way of representing a bunch of information, and it's more of a tool than it is something that is, well, a punishment. It's a great way to get a lot of information in a small space. So there's some organization, there's some labels that are worth knowing. So first, periods are the rows on the periodic table. So this is, say, period 1. This down here would be period 2. This would be period 3. All the way across, and this is period 4. You may remember that this might correspond with energy levels as well, talking electron configurations. The vertical columns, those are called groups. They're also called families, so either one of those works. Families or groups for the columns. And we typically will have this family to know, the second column family. We kind of skip over transition metals a little bit, and then you've got column 3, column 4. These are all different families. And we'll get into the names a little later. So there's a further way to classify these. Columns 1 and 2, and then columns, this is actually column 3 through 8. Those are called the representative elements, and there's some reasons for that. They have representative properties. They're somewhat predictable in their properties. They all end in either the s configuration or the p orbital configuration, which gives them somewhat predictable properties, like I said. So those two sets are called the representative elements. We spend most of our time in this class dealing with representative elements. Two different classifications are the transition metals and then the inner transition metals. So right down here in the middle, these are the transition metals. They're transitions maybe in a sense because you have metals and then they transition. You end up in the non-metal side over here, and we'll talk about that in just a minute. The inner transition metals, and remember, these are not a separate periodic table. They're just tucked in right here between barium here and lutetium here, and then you've got radium and lawrencium here. They're tucked in between. So, and the reason for that, I think, is really just a printing issue because the periodic table would be pretty long otherwise. So yes, transition metals and then inner transition metals. Now, another way to classify the periodic table is by the type of element. There's three main classes of elements. You've got metals, which are the majority of the elements. It's about 80% of the elements that exist are metals. You have nonmetals over here on the right-hand side. And then this middle area here are the metalloids. And it's kind of a staircase on the way down. You'll see a bit of a staircase on most periodic tables. This is just kind of a basic dividing line. You've got boron, silicon here, germanium, arsenic, antimony, tellurium, and polonium, and then astatine. These are your metalloids. Metalloids, they're also sometimes called semi-metals. And the reasons for that we'll discuss in just a moment. So looking at metals versus nonmetals, We're going to look first at some properties of metals, and this is really how you would distinguish one from the other. Metals are mostly solid at room temperature, so basic room temperature, 25 degrees Celsius, you're going to have a solid substance. There are a couple of exceptions to that. There's one exception, that is for mercury is a metal, but it is liquid at room temperature. Another property is that they conduct heat and electricity very well, so if they are exposed to heat, they will conduct it. Likewise, an electric current can pass through them. That's why a lot of our wiring is metal. They are ductile, which means they can be made into a duct or drawn into a wire. And then a last property is that they are malleable. Malleable means flexible, so they can be bent, hammered into shapes without necessarily breaking form. Properties of nonmetals, on the other hand, they are mostly gases at room temperature, and there's plenty of exceptions to that, but mostly they're gases. But sulfur is a nonmetal, that's solid at room temperature. Phosphorus is a nonmetal, it's solid at room temperature. But the good majority of them, of the nonmetals, are gases. And I guess because of that, but also for some other reasons, they're very poor conductors of heat and electricity. They don't do such a great job at that. Also, the properties of metals being ductile and malleable, nonmetals are, well, neither of those. They're not ductile and they're not malleable. The word there for that would be brittle instead of malleable. If you were to hit it with a hammer, most nonmetals would shatter into pieces as opposed to just bending. Now, semi-metals or metalloids, on the other hand, they're kind of in between. Their properties, they don't necessarily have a list of properties, but they're kind of both in a way. They're sometimes called semiconductors, right? Silicon is a pretty famous semiconductor. It's used for a lot of electric circuit boards these days. They kind of conduct, they kind of don't. They're somewhat of a good conductor of heat and electricity, but they're not great at it. So again, they're sort of in the middle of these metals and nonmetals. Moving on to another layer of organization, we need to know group and family names. And so I'm going to list them down here pretty quick. Group 1A, that first column, is called the alkali metals. Now hydrogen is at the top of that, but it's not considered an alkali metal because, well, it's a nonmetal. It's a gas at room temperature. It doesn't conduct heat or electricity, so it is not part of that family, even though it's at the top of the column. Group 2 is known as the alkaline earth metals. And again, that's column 2, starting with beryllium on the way down. Now we skip the transition metals. We're going to stay within the representative elements. So group 3A, and that A stands for the representative elements. So those first two columns, 1 and 2, then you skip the transitions, and then you hit the boron family. So it's group 3A, but in some cases it'll be known as 13 or group 13 because sometimes the transition metals are not skipped in the numbering. There's 10 of them there, so it's group 3A or group 13, either one. It's known as the boron family. Group 4A or 14 is known as the carbon family. Group 5A or 15 is known as the nitrogen family. 6A and 16 is known as the carbon family. Group 7A or 17, we're kind of back to the stranger names, is the halogen family. So that's the fluorine, chlorine, bromine, etc. Those are known as the halogens. And then finally, group 8 or 18 are known as the noble gases, also sometimes called the inert gases. Inert because they don't react. They tend to be found by themselves in nature. Now, we're going to talk for a minute on the next slide about why they're called families. So, classifying these elements, let's take maybe a step back to a previous concept, and I want you to pause the video and write the electron configurations for each of these 4 elements. So just for practice, and then also to show something that's relevant to this chapter. So pause the video, write out these 4 electron configurations, and then we'll pick it up again. Okay, so you should be back. Hydrogen is 1s1. So that's the electron configuration. The configuration of lithium is 1s2 and then 2s1. Sodium, 1s2, 2s2, 2p6, and then 3s1. Maybe you're seeing a pattern here. Potassium, again, it ends at 4s1. So the fact that these all end in the same outer structure, notice lithium has that one valence electron. Okay, it's the outermost electron. This is the lowest energy level, it's full. The outer energy level has an S1 configuration right here. Sodium as well, 1s2, 2s2, 2p6. These are all the lower energy levels. They're full. They're not going to be reacting because all the electrons are paired up. This is where the action happens for most of sodium's chemistry. This is where the reactive electron is. There it is on the outside. So you can see there's a bit of a parallel. Potassium would have the same. It just has more electrons underneath, but the outermost electron that can react, that one valence electron, is the same for each element in the family. Now because of that, because they have the same outer structure, they lead to similar chemical properties. Not exactly the same because the size of the element is different and that leads to some different properties, but they're very similar in how they're going to react, the types of compounds that they're going to make, and this is the reason why they're called families as opposed to, say, a group is another way to say it. They're much more similar to themselves in the column than to any other element on the table. So to recap these two sections here, we looked at the organization of the periodic table and some of the basic names like groups and families and periods for how we look at it. We looked at metals, nonmetals, and metalloids as the three basic classifications on the periodic table, the three types of elements, and a little bit on the properties of each of those. And then finally classifying elements into their families and the reasons for that based on electron configuration. And so that's it for the intro to the periodic table, and we'll be looking at a little bit more in the next lecture.